Hi, this is a demonstration about ClimaCheck on-site software. When the software is installed on Windows, there are three shortcuts: ClimaCheck Standard, ClimaCheck Advanced, and ClimaCheck Demo. I've opened now ClimaCheck Demo, and this is for demonstration purposes made with all previously measured data. This is the window that we get first when we open the software. In here, we should fill the measurement that we're doing. So as an example, I will write chiller. Next, we need to decide the system type. In here, we can choose water-cooled chiller, air-cooled chiller, supermarket, medium temp, low temp, and so on. Now I know that this measurement has been done on water-cooled chiller, so I will choose that. It is important to select the correct system type. The reason is that the reference temperatures of the SEI are calculated depending on the system type. So it will be different calculation method when using a water-cooled chiller and an air-cooled chiller. So it's important to choose the correct system type so the reference temperatures are calculated correctly and the SEI is calculated correctly. We can then go on and to fill more information about the measurement that we're doing. I'll just write an example here, just to have it, and we click OK. The next window we get is a reminder about the refrigerant. In this case, the pre-selected refrigerant is 134A, and I know that this measurement is being done on 134A and I don't need to change it. But if we need to change the refrigerant, we can do so from the refrigerant menu. The software language can be changed as well. So when we go to settings, we have the program language. And this is the language that we see in the menus. And we have some example languages. The workbook language itself can be changed as well. And this is all the description we see in the workbook. For example, the names of the columns. What we can also change is the units. Default is the SI units, but we can click on this to change it to IP units. Now we'll go through the tabs in the software one by one. The first tab is the script, and this is the description of the chiller, the measurement that we've done. The information is gotten from the system information, and that is, we can see it again here under view, enter system info. So whatever we fill in here will be shown in the descript tab. Next, we've got the report, and this is showing the data in tabular form. Now in ClimaCheck Demo software, we are using previously measured data, and to get the data, I will click on Start, and the data will start filling in. Now when we actually do a measurement, you will see that the data fills in every 5 seconds or every 60 seconds, depending on what you've chosen in here. I will stop the measurement. Now, what we see in here is the data sets for each time. So this is done every 10 seconds. And for each data set, we have input values. So for example, here we've got the chilled water in and out temperatures and some calculated values. For example, the difference between these chilled water in and out. At the top here we have some limits, minimum and maximum, and this is to have a certain idea on what we're expecting from some variables. For example, we've set up that the superheat is between 4 and 7. And what we notice here is that the superheat is outside the limits, so the value is in red. If you hover on the values, you will see an explanation on what can cause a low superheat and a high superheat. This is the case for all the red squares in the limits. There are explanations on what is causing to be outside the limits. Some of the limits are not constant values, they're equations. So for example, here 4 and 7 are constant values, but the evaporation temperature is an equation. It depends on the chilled water out temperature. So the limits is not constant, but it depends on the chilled water out temperature. Next step is a constant step. Here we have some constants that are used in the calculation. The first one is a minimum compressor capacity to log. This means whatever value we have above this one will be logged in the software. The next one is a minimum compressor capacity to calculate COP. And this might be something you might want to change if you're measuring in smaller systems. The default value here is 0.5 kilowatts. This means anything below 0.5 kilowatts will be considered as a turned off compressor. But if you're measuring in smaller systems and you know that your compressor runs usually 200-300 watts, then you might want to change this value. To change it, click on the cell, click up here, and change it to, for example, 0.1, and click enter. This means that anything below 0.1 kilowatts will be calculated. Next is the thermal efficiency of the compressor. And the default value here is 0.93. This means that the 93% of the electrical power going into the compressor goes to the refrigerant cycle. This means that there is a 7% of heat losses. This is the default value and matches quite well for compressors that are not actively cooled. But if you have an actively cooled compressor with a fan, for example, or if the compressor is sitting in front of the condenser, then the fan is also cooling the compressor, then in that case the 7% heat losses are not correct anymore. In that case you will need to change the thermal efficiency of the compressor. Some other interesting values are the external motor efficiency, and this is when we have an external motor, an open drive compressor. There are losses on the drive, so we would like to change this. Now the default is 1, it means there is no losses and there is no external motor. But if you would like to, if you have an external motor, then we have some nominal values here, some information about it, and you can change this one into 0.92, for example. If there is a VFD in the system, you can also enter the losses in here. Now the VFD will have 2 to 3% losses, so in that case you might want to change from 1 to 0.98. Finally, we've got some constants about the secondary fluids, and this can be water or glycol on the cold side and water on the warm side. First we've got the reference temperature, and this is calculated depending on the system type that you've chosen at the beginning. I chose to have a water-cooled chiller. In this case, reference temperature is the average value between the water inlet and outlet. Same on the cold side. You don't need to write down the equations, you just need to select the correct system type, and the equations will be changed automatically. The remaining is the CP and the density, and these are used to calculate the flow on the secondary side. These are not used to calculate COP or cooling and heating capacity, just the secondary side flows. Next tab is the input tab. And in here we have all the measurement points that are interesting to the system and all the incoming data. These are shown on this column, the raw data. This is what is coming in, and here we can decide to change these values before they are used in the calculation in the report tab. Why do we need to do that? An example is if we've extended or shortened the temperature cable. And in this case, because the cable has some resistance, if we have extended the cable, then that resistance will be added in form of temperature, but we know that the temperature is coming from the cable resistance, and we can take that off. We know, for example, that our cable is adding 0.2 degrees, so what we can do in here is to click on the offset and change this to 0.2. And what we have in here is that we're measuring 9.8, but because of the offset, we're actually using it as 9.6. So if I go back and run this again, so now we have an offset on the chilled water in temperature. So 9.8 becomes 9.6. Another example is if we are measuring one of the three phases on the compressor. The reason to do that might be that we need to measure several compressors and we only have one power meter. In that case, we might decide to just measure one of the phases after making sure that the three phases are equal. So what we do is to measure one of the phases, but because it's one of the three phases, we need to multiply this by 3. So what we can do is this is the power that we're measuring, and we need to multiply this by 3 if we're measuring one of the three phases. So we can change this one to 3. And what we've got here is that we're measuring 56 kilowatts, but we actually will use 168 in the calculations. Now if I go back to the report tab, we have the power in here, and it was 56. Now I added multiplication by 3, and I'm changing the power. Next is the custom sheet, and in here we can compare the measured value to nominal or baseline values. This might be important if you want to make a comparison between what we're expecting from the system, or a comparison between two states if you've made a change into the system and you want to compare it, what the result is from this change. So in this column you've got the measured values, and this is the latest values that's arriving to the software. What you can do is to fill in the nominal values. If you know from the manufacturer data, you can fill them in just so that there is some comparison. What you can also do is to compare to baseline. And this baseline, we can actually take it from the report tab. We just have to select the data point that we want to compare to. Let's say I want to compare my data to this one, I would say that at this point, this is my baseline, and after this I've made some changes, and I want to compare these changes to before, and the before is this point. What we can do is to select this row by clicking on the row number, right click, and copy line to custom sheet baseline. And what happens is that the baseline is now filled with this data set. And my measurement will be compared to this one. So whatever we have, we can run it and have the comparison in here. This is a good page to make a comparison, or if you're making frequent measurement on the system, to see the difference between the last measurement and the current measurement. The next two tabs are for the graphs. And the graph functionality is the same. We are just having different variables in each of the graphs. Here we're presenting several variables over time, and what we can do in here is to select or deselect, hide and show the values. For example, I want to hide and chilled water in and out temperatures, and maybe I'm making a report and talking about the condenser performance. In that case, I maybe don't want to show the chilled water in and out temperature, so I can just deselect them and show whatever's interesting for me. If the interesting value is not in this list, and in that case I can go in here and data setup and add additional values. So we have a long list of variables which are available in the software, and if I want to add one of them to the graph, then I can select this one and say SI, IP, or SI and IP. What this does is that I want to show this variable in the SI graph. So if I'm looking at the software in SI units, I will see it. But if I'm looking at the IP units, I will not see it. If you want to show this variable in both graphs, then you can select SI and IP. Here you can also change the color of this variable. And if you want to have a dashed line, or if you want to show it in the right y-axis. What we can do here as well, when hovering, then you see the variables, the values. It's a good point to take a screenshot if you're talking about a particular component of the system. And it's good to show only those variables and hover on them and take a screenshot of this graph. If you want to zoom in to a certain point, then you can hold Shift and you will get the magnifier cursor. You can select wherever you want to zoom in. To zoom out, we click on the zoom out. The functions on the other graph are the same, we just have different variables. Next, we've got the dashboard, and in here we're presenting the SEI and the sub-efficiencies. First, we've got some information about the measurement, and this is the exact same information that we filled in the system info. It will be shown in here. It's a good idea to write this information, especially when making several reports, when making several measurements, to have this information in the dashboard, because the dashboard is a very good point to take a screenshot and to just put it in the report, because it summarizes the whole measurement. What we also see in here is a graph showing how the system is behaving. What's important to think about doing analysis of a system is to always choose stable operation. The part where the compressor starts or stops is not that interesting compared to stable operation. So this graph will help identify when we've got a stable operation. And if you want to change what you want to show in the dashboard, if you know a particular time that you want to show in the dashboard, you can go to the report, select that row by clicking on the row number, right click, and copy line to dashboard. This will update the dashboard with that particular time. What we see in here is the SEI, the sub-efficiencies, refrigerant, compressor, condenser, evaporator, and all the KPIs related to those efficiencies. That's why this is a very good page to include in the report. It will show how the system is working, which parts we can improve, and how can we improve these. Next, we've got the flowchart. And in here, we're looking at the data that has arrived last in the measurement. So this is live data, and this flowchart will be customized depending on which system you're measuring. So if you've got a template for 2 circuits, the flowchart will show a 2-circuit template. In here, we see measured values and calculated values. And this will always be the last value that has arrived. So if I continue the measurement, you will see that the values are updating. If you want to change the values to a certain time, then you can do that again from going to the report tab, selecting the row that you want to show in the flowchart, right click, copy line to flowchart. So if you go to the flowchart, it will show the date at that point. This is a good idea when making reports. You don't want to just have some random data set in the flowchart. It will be a good idea to show a representative point. In that case, you can go to the report and select the row that you want to show in the flowchart. Now these are the tabs in the software. Now I mentioned that this is the standard template, but we have many other templates depending on the system that you're measuring. The software includes 3 other templates for de-superheater, subcooler, and suction gas heat exchanger. And we can change that by going to File, New ClimaCheck Workbook from Template. So this will allow me to choose the template that I want to run. It's asking if I want to create a new template anyway. Yes, it will erase the data that I have. That's fine. And what we've got here are the 4 templates that are included in the software. If you're measuring on different templates, then you can contact us to add those templates. Now I will, for example, do the measurement on a subcooler, system with a subcooler. So I click on that. I have the template in here and template instructions that come with the template. So I can double click on that and open the template instructions. What we've got in here are the sensor placements. So what we're saying here is that the first sensor will be connected to discharge, the first pressure is connected to high pressure, and so on. So this flowchart shows where to connect each sensor. There's also information in a table form, which includes the variable names for each of these measurement points. Why this is important? Because the template, so I will select this template, and we'll ask to enter the system information. Chiller, water-cooled chiller, okay. And the refrigerant is 134A. Why it is important to have the correct sensor placement as in the instructions, because each template comes with a data source. And the data source defines which sensor corresponds to which measurement points. And if we follow the instructions, then we don't need to make any changes in the data source. So right now we've selected the template, but we also need to select the correct data source that comes with it. What we do is to click File, Open Data Source, and it will open that folder of the template. So in this case, we will use a PA Pro 3 to do that. We have also data source for PA Pro 2. So if we get the PA Pro 3, we select the PA Pro 3 data source. In this case, it will try to connect to the PA Pro 3, but I don't have that at the moment. So this is a reminder about the refrigerant. If you want to change the refrigerant, we can go to the refrigerant menu and change it here. This is the data source view. And you can access it by clicking the tab in here, data source, on the bottom right corner, or by clicking on View Data Source. Here we've got 4 columns. The first column shows all the variables which are available in the software. This is a long list and you don't need to learn any of it. The third column shows all the sensors available in the PA Pro 3. And the second column connects those two. So connects the sensor to the correct variable. And this is according to the instructions that comes with the template. So in the instructions, we say that the high pressure is measured by the first pressure, and this is what this line says. In the instructions, we see that we have high pressure variable, which is called PT RHPA, and that will be connected to the first pressure, which is called NX401. And the list goes on for each variable. So the compressor out, the discharge, the variable is called TTRCompa out, and it's connected to the first temperature. We see that we've got some available sensors which are not connected to anything. For example, the 8th temperature, we haven't connected to any variable. But let's say we want to connect it to an extra variable, just to have it some value in the report. What we do is to click on the sensor that we want to connect to a variable and choose the variable that we want to have from this list. So for extra temperatures, you can select TTX8, which is the 8th temperature. And when you selected the variable and the sensor, click on Connect. In this case, the connection appears in the second column. When you make any change to the data source, you need to click on Reload Imp. And this, you need to exit the data source first, and you can click on Reload Imp. This basically saves the data source to the template. So any changes that you made, it will save to the template. So to recap, to change the template, we go to File, New ClimaCheck Workbook from Template. And we've got a list of templates. They come with the software. And here we can select the template that we want, and we can also see the instructions. The instructions will have a list of sensors we need to connect to the system, and if we follow this list, then we can just select the corresponding data source for the template To do that, we go to File, Open Data Source, and we select the corresponding data source. So I will do that for paper 3, let's say. Now, if you know that you're measuring on a certain template and data source most of the time, then you can select those to be the default template and data source, so that every time you open the software, whether ClimaCheck Standard or ClimaCheck Advanced, you will get that template. To do that, we go to Settings, Preferences, and the first two part in here show the default template and the default data source. So if we know that we always measure on systems with a D-superheater, then we can change the default template to the D-superheater template, and we can change the default data source to the D-superheater data source. In this case, we don't need to go and choose a template every single time we open the software. There's one important feature in here, is the Save Scheduler. This is very important when measuring on doing longer measurements over a few days. So in this case, we would like to have smaller files, because if we do a measurement for 2 or 3 days or a week, the file becomes big, it will be difficult to open, it will be difficult to analyze. So in that case, we would need to use a Save Scheduler. What this does is it saves a new file at a defined time. So we can select it, and we can go to the Save Scheduler tab. So we'll clear the settings here. So in here, we can decide at what point we save a new file. And what I would recommend is to select all the days and select midnight and click on Add. What this does is that at midnight every day, when you're doing a measurement, it will save a new file and start from a new file. So you've done a measurement during the day, midnight arrives, it saves that measurement and starts from a new file. This will help to keep the files manageable and to do an easier analysis. Finally, I would like to show the PA Pro 3 configuration menu, which is necessary to make any configuration changes in the PA Pro 3 on-site hardware. So to reach that menu, you click on Performance Analyzer Pro and click on PA Pro 3 configuration. This will open up a new window where you can configure the PA Pro 3. That's all for the software.